Find the volume of the solid when the area bounded by the curve y equals x minus x squared and the x-axis is revolved around the x-axis. Okay, pause it and try it, and I will give you my solution. All right, let's first start out by graphing y equals x minus x squared. I can see I have x-intercepts at 0 and 1, and I want to rotate this area bounded by the curve and the x-axis about the x-axis. So if I took partitions from the curve to the line of rotation, I can see on there there's no gap at all. So the bottom of the partition is touching the axis of rotation. So that tells me that this is a disk problem instead of a washer problem. And I'll show you over here that we had on the first page what shape this would create. And this would create kind of that football or lemon shape on the left there. All right, so the disk method formula, we're going to have a pi out in front of our integral. It will be the integral from a to b of big R of x, the quantity squared, dx, where R of x is the distance from the curve to the line of rotation. So in this case here, we're going to have from 0 to 1, because that's the intersection on the x-axis, and we're going to put in our curve, x minus x squared, that is our big R of x, and we're going to square that. So if we simplify that, we're going to get pi times the integral from 0 to 1 of x squared minus 2x cubed plus x to the fourth dx when we multiply that out. All right, let's do the integral now. So if we take the integral of x squared minus 2x cubed plus x to the fourth dx, we would get x cubed over 3 minus x to the fourth over 2 plus x to the fifth over 5. And then we're going to plug in our limits of integration from 1 to 0. So we would get 1/3 minus 1/2 plus 1/5, and that comes out equal to 1/30. But we can't forget that we have the pi out front we have to multiply by, so our answer would be 1/30 pi.